This is Andrew Oborn, Danica Christensen, and Rachel Bixel, and today we will cover Chapter 13, Architect for Low-Risk Releases. In this presentation, we will discuss eBay's use of the Stringler application method, architecture that enables productivity, stability, and safety, the architectural archetypes, Amazon's use of evolutionary architectures, and what the Stringler application pattern is. DevOps organizations such as Google, eBay, and Amazon all went through evolutionary phases in their architectures to keep up with demands of the market and address current needs with their companies. Randy Shoup, an engineer at Google and former architect at eBay, observed that both companies were currently in their fifth full architecture rewrites. Although each phase of architecture is necessary in its own way, it's important to keep migrating from current architecture to needed architecture. eBay does this by releasing small pilot projects which gives them a greater understanding of the issues they are trying to solve. An example of this is when Shoup's team at eBay wanted to move parts of the site to full-stack Java. They did this by focusing on the highest revenue areas, stopping only when business return did not justify the effort. They used the Stringler application pattern, putting the existing functionality behind an API for reference and using new functionality to support the new architecture. The Stringler application pattern is particularly helpful for migrating monolithic applications and tightly coupled services to loosely coupled architecture, leading to safer environments.
A loosely coupled architecture allows for small, productive teams that can make small changes that can be safely and independently deployed. With well-defined APIs, testing, creation of contracts, and SLAs, it's easier to coordinate between teams. Google has used this type of architecture in Gmail and in its Google Cloud Data Store. Google Cloud Data Store is one of the largest NoSQL services in the world, and it only has about an 8-member team. This is due to the fact that it's based upon layers and layers of dependable services built on one another. Also, Google and Amazon have shown how using these service-oriented architectures create flexibility and scalability. Even though they have tens of thousands of workers, they use small teams to increase productivity. Most DevOps organizations start out with a tightly coupled monolithic architecture. This is a good architecture early in a product life cycle. Yet it becomes vital to re-architect as the business gets larger to survive and to excel. It is typical that architecture needs changes over time. There are 3 major architectural archetypes: monolithic V1, monolithic V2, and microservice. Monolithic version 1 has all functionality in one application and is resource efficient at low scales, but is lacking as scaling increases. Monolithic version 2 has a set of monolithic tiers. It also has a single scheme. Deploy and join queries are easy, but some of the downfalls is that coupling usually increases over time and it is all or nothing scheme. Microservice works better at larger scale organizations because there is independent scaling, performance testing, and deployment. You can also optimally tune performance. The downsides are network latencies, many cooperating units, and small repos, and more tooling and dependency management. It is best to evolve into the architecture that best suits the current needs of the organization.
Amazon.com has been the subject of study for many of its business practices. One such practice is the architecture transformation that occurred there. When Amazon started, in 1996, it was a monolithic application with a database on the back end. The application grew and began to hold all business logic, all display logic, and all other functionality that Amazon had. As time moved on, the application also grew and became very complex and tangled with Amazon's sharing relationships. This meant that individual pieces of the application could not be scaled as needed. There were a lot of complex software pieces combined into a single system. The system could no longer evolve. Leaders at Amazon saw this problem and began working towards a solution. This solution was to decentralize the services platform and create a fully distributed system. This allowed for the system to evolve and grow. 3 main things can be learned from Amazon's experience. The first is that strict service orientation is a great way to isolate applications. With isolation, a level of ownership is achieved and the applications can be controlled. Second, client systems are not able to access databases directly. This allows for easier scaling and servicing. Third, the development and operational processes benefit by being able to innovate quickly. Amazon has increased its deployments to 136,000 deployments per day. Strangler vines grow in a tree and continue to grow until they reach the soil. Once in the soil, they will eventually strangle and kill their host tree. If our current architecture is too tightly coupled, we can decouple parts of the functionality from the architecture. This will enable isolation with independent teams and reduced entropy. When functionality is decoupled, it is placed behind an API. This creates versioned or immutable services. Versioned APIs allow us to modify services without affecting other systems. This further decouples functionality and in turn shrinks massive legacy functionality in applications. When Strangler applications are in use, systems are very complex and often contain idiosyncrasies. This generally results in replicated functionality. When functionality is decoupled, this is avoided. Additionally, an upfront analysis can be done to prevent these problems in the future. In conclusion, we talked about transitioning to new architectures and eBay's experience with the Strangler applications. We spoke about loosely coupled architectures using the Google as an example. We covered monolithic and microservice archetypes and the pros and cons of each. We also explored Amazon as a case study and their experience transitioning, as well as lessons learned from that experience. Lastly, we covered Strangler application patterns and the problems that they can cause.